In this video, we'll be looking at quantities, units, and measurement in physics. This is Samuel and I can welcome you to Edison Educator's channel. So please, if you're not subscribed to this channel, hit the subscribe button right away, and also like the video and click the bell icon so that you always be notified whenever we upload a new video. So, like I said, that we'll be looking at quantities. We'll be looking at quantities, units, and measurements in physics. So, are quantities that important that we need to learn them? Yes, quantities are highly important. So, without wasting your time, we are going to go to the lesson right away. So in this lesson, we'll be looking at quantities, units, and measurement. What is a quantity? What is a quantity? A quantity, a physical quantity in physics, is any physical property of a material that can be measured, of a material or a system that can be measured or quantified using numbers combined with their units. So I said it's a physical quantity in physics is any physical property of a material or a system that can be measured or quantified using numbers combined with their units. Take for instance, if we have a block, a rectangular block of concrete. This has, at the end of the day, we could go ahead and measure the length of this concrete, of this rectangular block of concrete. We could measure the length, we could measure the height, and we could also measure the breadth. Okay. So the length, the height, and the breadth which we are measuring are actually physical quantities. They are quantities that are measurable. So you could measure the length, for instance, and at the end of the day you got 5. But if you write down 5, they ask you what's the length of this block. You say 5. It is wrong. It's not correct. Why is it not correct? There is no unit attached. 5 what? Is it 5 millimeter? Is it 5 centimeter? Is it 5 inches? Is it 5 feet? So 5 does not make any meaning. To convey complete meaning, to make sense, to pass complete information, to completely specify the length of this block, you have to state the unit. If you say 5 centimeter, then you've passed complete information. Anybody whom you tell 5 centimeter can actually visualize how long the length of this block is. But when you just say 5, it makes no sense at all. Okay, so at the end of the day now, we could measure the length, the height, and the breadth. These are all measurable quantities. And for instance, if they ask you to find the volume of a block, is it possible to get the volume? Yes, it's possible. There might be ways we could actually measure the volume, but we can now bring in mathematics. We know that this shape of this block is like in a keyboard, and the formula for the volume of a keyboard is length times breadth times height. So once you measure the length, the height, and the breadth of the block, you could use mathematics, this mathematical formula, to find the volume of the block. Okay? You could use mathematics to find the volume. And there are other things you could also use mathematics to find, like the area of each face. This block has 6 faces. You could find the area of each face, and from there, once you get the area of each face, you can add up the area of the faces to get the total surface area of the block. Those are still quantities you could find out. So right now we are going to move on to what we call quantities are actually divided into two types. So we're going to move on depending on how they are gotten. So before we talk about fundamental quantities, remember what I said about the block, that you could go ahead and measure the length, the breadth, and the height, and also you could find the volume by multiplying the length times the breadth times the height. That will give you the volume. So that clearly spells out what fundamental quantities and derived quantities are. For the case of the length, the breadth, and the height, we just measure them and got the values directly. But when it came to volume, before you could get the volume, you had to combine three quantities together: length, breadth, and height. So the volume is actually a derived quantity. Volume is a derived quantity. Derived quantities are quantities that are obtained when you combine two or more fundamental quantities. Fundamental quantities are those you just get, they are on their own. Length is a fundamental quantity. Breadth is a fundamental quantity. Height is a fundamental quantity. They are on their own. They are not obtained by combining other quantities. But when it comes to volume, for you to get volume of this block, you have to multiply length, breadth, and height, three fundamental quantities, together. If you were to find the area, surface area, the same thing will still happen. You have to combine the three, the same length, breadth, and height in different ways at the end of the day and add them up. So in fundamental quantities are basic quantities from which other quantities are formed. Fundamental quantities are what? Basic quantities from which other quantities are formed. They could be referred to as basic quantities. They are basic quantities from which other quantities are formed. While the derived are obtained when you combine two or more fundamental quantities together. So, example of fundamental quantities. What are examples? Let's look at some examples of fundamental quantities. Examples are, we have mass, length, time, electric current, amount of substance, and temperature. And luminous intensity. These are all fundamental quantities. They are on their own. They are on their own. They are what? On their own. Now, mass, length, and time are very important fundamental quantities. These are the three most common fundamental quantities that give rise to most of the other derived quantities. Most of the derived quantities are gotten by combining mass, length, and time. So these are the three common ones, the three most important fundamental quantities when it comes to deriving other ones. Okay. So, what are examples of derived quantities? Examples of derived quantities. We have, for instance, we have speed. We have speed. We have velocity. We have density. We have momentum. We have acceleration. We have pressure, density, force, impulse, to mention a few of them. Area, volume, these are all derived quantities. Okay? So, next, we are going to move on to units. What are units? 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 In physics, to specify a quantity completely, the unit must be attached to the numerical value, just like I told you that. If you say the length of that block was 5, it does not make sense. But when you say 5 centimeters, it makes sense, because somebody will have an idea of how long that block is, how long the length of the block is when you say 5 centimeters. But when you just say 5, it does not make sense. So unit actually completely specifies a quantity in physics. Quantities in physics are completely specified when you attach a unit. Take for instance, if you measure the mass of a body, the mass of an object, and you ask, what is the mass? You say 20. The person will just look at you. If the person is not a novice, if the person knows what he or she should know, you just look at it. 20 what? 20. 20 doesn't make sense. But when you say 20 kilogram, 20 gram, 20 centigram, then actually the person has an idea of how massive or how heavy that object is. So units are very important in physics. When you solve a problem in physics and you don't attach a unit, automatically you fail. You didn't get the answer right. You failed that question. So have it in mind that units are very, very important. So just as we have fundamental quantities and derived quantities, so also we have fundamental units and derived units. What are fundamental units? Fundamental units are the units of the fundamental quantities, while derived units are the units of the derived quantities as well. So we're going to look at some examples of fundamental units and derived units. So for the fundamental quantities and their units, we have fundamental quantity. I'm just using this as a shorthand for quantity. Then the fundamental unit and the unit abbreviation. We have length. The SI unit of length is meter. The unit abbreviation for meter is m, small letter m, that is lowercase m. For mass, the next one we're looking at is mass. The fundamental unit of mass, the SI unit, is kilogram. Kilogram, unit abbreviation is small k and small g, kg. Then the next one is time. The unit abbreviation for time is SI unit. Time is measured in second. That is the SI unit. Time could be measured in years, time could be measured in days, time could be measured in hours, in minutes. But the SI unit is what? Second, which is lowercase letter s. Other listen, we have amount of substance. Which is measured in the unit is mole. The unit abbreviation is MOL. Then the next one is electric current. Electric current could be measured in unit of ampere. Ampere. The unit abbreviation is capital A. Another one is temperature. Temperature is the next one. The fundamental unit of temperature is Kelvin. The unit abbreviation is small k. Then the last one we're looking at is luminous intensity. Luminous intensity. The unit is candela. The unit abbreviation is capital C with a small d. So these are fundamental quantities, these are the fundamental units, and these are the unit abbreviation. So have a look at this one. We're going to move to derived units. We're going to look at derived units. So these are the fundamental quantities, these are the fundamental units, and these are the unit abbreviation. So for the derived units, we have derived quantities, derived units abbreviation, and how the quantity was actually derived. So the first quantity we're looking at is area. How is area gotten? If it depends on what you're looking at, but either way, the units will line up, is going to be the same thing. Area for a square or rectangle is length times breadth. Area is what? Length times breadth. Then the derived unit is what? The derived unit is length. The unit for length is meter. The unit for breadth is also meter as well in SI. So the derived unit is meter square. This could be called meter square or square meter. Okay, this is the unit abbreviation. In words, this is going to be called square meter or meter square. This is going to be called square meter or meter square. So these are this is the derived unit. So then next we're going to look at volume. How is volume derived? Volume is length times breadth times height. Length is actually meter, breadth is meter, height is in meters as well. Those are in SI units. Length is in meter in SI units, breadth is in meter in SI units, and height is in meter in SI unit as well. So this gives rise to cubic meter or meter cube. So you could, the derived unit here is cubic meters or meter cube. Okay. So another one, we've looked at area, we looked at volume, is density. How do you arrive at density? Density is equals to mass all over volume. Mass divided by volume gives you density. Mass divided by volume gives you density. Now, what is the SI unit of mass? Kilogram. And what is the unit of volume? We have cubic meters here. So from here now, the SI unit of density, the unit abbreviation is going to be kilogram per meter cube, which can be written this way or this way. In case you're confused here, you could ask me, I will explain why it's so. This is kilogram per meter cube, or kilogram per, the same kilogram per meter cube, kilogram per meter cube, or kilogram per cubic meters. This is called, I don't want to write this down, this is based on derived unit. In words, this is kilogram per cubic meters, or kilogram per meter cube. These are the two ways it could be written. Now, you might want to know why did this, you might easily understand this one. But why did they change it? This is for indices. This is kilogram over m raised to power 3. When this goes up from indices, law of indices, when a power, positive power in the denominator goes up to the numerator, it becomes negative. So this is why this transforms to this. Okay, so we still have some more. So let me rub up the board. So we have treated area, volume, and densities thus far. So the next one is speed. Speed, the formula for speed is equals to distance all over time. And distance is actually a kind of length. Distance is actually a type of length. So you have that speed is equals to length all over time. Distance is a type of length. Okay? So length, distance is in meter, while time is in second. So this, based on indices, this is m over s raised to power 1. So when this comes up, you have m raised to power m s raised to power minus 1. When this s raised to power minus 1, power 1 comes up, this is m over s. S is carrying power 1. Because it is 1, that is why it is not written. So, but when you take it up, when in the negative, you have to put the 1. Okay. So, this is meter per second. It can be written this way or as m/s. This and these are just the same thing. m/s. ms raised to power minus 1. So another one is velocity. So I would like you to do velocity and acceleration yourself. I'm not going to work out acceleration and velocity for you. Okay. So another one is pressure, or let's look at force. So force is equals to what? Mass times acceleration. But I would like you to work out the one for force as well. because already if I work it out, that means automatically I will solve acceleration. But at the end of the day, you are going to get a value. Whatever value you will get for mass times acceleration is going to give you a combination of units which will be equal. That unit will be equal to the Newton, the SI unit for force. But get the correct combination of mass and acceleration units together. That will now be equal to Newton. So I think let me, is there anyone I will solve that won't expose the ones I've asked you to try your hands on? Let me see. Okay, let me solve velocity, and I'm going to leave these two for you. Let me solve velocity. Velocity is equals to displacement all over time. That is changing displacement all over time. Displacement is a kind of distance, a kind of length, which length is, the SI unit is meters, time is second. So at the end of the day, velocity is meter per second, just like speed. Velocity and speed have the same unit. Okay. Although as you go further, they will tell you that velocity has direction. You must take the direction in which velocity is taking place. Okay. So from here, we are going to move on to momentum. Momentum as a derived unit. Momentum. So momentum is equals to mass times velocity. Now, mass is kilogram. Velocity is meter per second. Let me write it this way. So this will combine to give you kilogram meter per second as the unit of momentum. So I would like you to try out some more, get some derived units for the following derived quantities. I've already given you acceleration, force. So the next one is going to be impulse and work and pressure. So try this out. Just make sure you try these ones out. Okay, so we're going to stop the lesson here. Thank you for joining us, and watch out for the next lesson. Well, thank you so much for staying with us to the end of the lesson. Really appreciate. So please, if you know you're not subscribed, please go ahead and hit the subscribe button and the like button as well. Then click on the bell icon so that you always be notified whenever we upload a new video. Then you can also connect with us via our social media handles. This is my WhatsApp number. This is my Instagram account, user account. So thank you so much for joining us, and bye.